All right, let's dive into something so fundamental that we almost never stop to think about it. Numbers. I mean, what are they really? And what does their incredible, almost strange power tell us about the nature of reality itself? Okay, check this out. In all places and for all time, 2 plus 2 equals 4. We all know that's true, right? It's just a fact. It's as true here as it would be on Mars. But why? Why is it true? That simple little equation, it actually cracks open this huge, profound mystery. Is math something we humans invented, or is it something we discovered?
So to really get to the bottom of this, we've got to understand that our whole idea of what a number is hasn't just been sitting there static. Oh no, it's more like an expanding universe of its own, growing for thousands of years. And each new layer, each new type of number, was basically created to solve problems the old numbers just couldn't crack. I mean, this journey starts way, way back. We're talking tens of thousands of years ago, with just simple tally marks scratched onto a bone. Then you fast forward to ancient Egypt, and bam, we get a base 10 system. And then you have these two world-changing ideas coming out of India. First, a symbol for zero, for nothing, and then negative numbers, to handle things like debt. And then finally you get to 16th century Italy, where mathematicians are just tearing their hair out over these unsolvable equations, and they dream up something completely wild, complex numbers. It really all starts here, though, with the most basic, most intuitive numbers you can imagine, the natural numbers. The counting numbers. 1, 2, 3, the ones you use to count how many coffees you've had today, or the number of episodes left in that show you're binging. They feel like the absolute bedrock of everything, don't they? Okay, so the next huge leap forward was adding zero and negative numbers into the mix. This created what we call the integers. And honestly, this was a total game changer. Because all of a sudden, math wasn't just about what you have, it was also about what you owe. But, this leap, it wasn't easy. For centuries, the whole idea of a number being less than nothing seemed, ridiculous. I mean, European mathematicians literally called them false or absurd numbers. It took a really long time, we're talking centuries, for them to finally be accepted as, real. So from there, things expanded again to include fractions, the rational numbers. But then, the ancient Greeks stumbled upon something that totally freaked them out. A discovery so terrifying, they tried to keep it a secret. They found numbers, like the square root of 2, that could never be written as a simple fraction. Ever. These were the irrationals. And the legend? The legend is that the guy who spilled the beans about them was drowned for heresy. Wild, right? And that brings us to maybe the strangest leap of them all, complex numbers. See, to solve certain types of equations, mathematicians basically had to invent, an imaginary number. They called it I, and it's the square root of -1. Think about that, a number that, by all logic, shouldn't even exist. And yet, as we're about to see, it turned out to be one of the most fundamentally useful ideas in all of science. So let's pull back and look at the whole picture. You've got this beautiful structure where each number system is nestled inside the next one, kind of like those Russian nesting dolls. We started with this simple act of counting, and from that, we've built this massive, abstract, and unbelievably powerful universe of numbers. And this is where we get to the central mystery of it all, the big question. Why? Why does this abstract world that we've either constructed or discovered, why does it map so perfectly onto the physical universe? I'm not exaggerating when I say this is one of the biggest, deepest questions in all of science. The physicist Eugene Wigner had a great name for it. He called it the unreasonable effectiveness of mathematics. He thought it was just a miracle, a wonderful gift, that these concepts, dreamed up in a mathematician's head, often with zero practical application in mind, turn out to be the exact language we need to describe how the cosmos works. It's unreasonable. And you want the most mind-blowing example of this? Remember that imaginary number, the square root of -1? The one that started out as just a clever trick to solve some niche equations? Well, it turns out it's not just useful, it's absolutely essential to quantum mechanics, our best theory of reality. You literally can't do quantum physics without it. It's what allows physicists to describe things like the phase of a quantum wave, which you just can't do with regular old real numbers. So, why? Why does the fundamental fabric of reality seem to speak the language of imaginary numbers?
And that question leads us straight into the heart of this huge philosophical debate. Is math something we humans invented, just a really, really useful tool we made up? Or is it a fundamental feature of reality itself, something that's always been there and we're just discovering it? So you've got these two camps, right? On one side, you have giants like Einstein, who called math a free creation of the human mind. Basically, we made it up. But on the other side, you've got most working mathematicians, and they really feel like they're discovering truths that have always existed. I mean, think about it. Was the Pythagorean theorem not true before Pythagoras came along? Of course it was. The idea that it wasn't seems kind of absurd.
I love this analogy from the mathematician Sergiu Klainerman. He says a mathematician is like a mountain climber. The mountain, that's the mathematical truth. It's this objective thing standing right in front of you. You can't just wish your way to the top. No, you have to find the path that's already there. You have to touch the stone, feel the rock to know you're on solid ground.
Okay, so follow this thought. If mathematics is something we discover, if it's an objective reality, then that presents a massive challenge to a worldview called materialism. You know, the idea that the only thing that's truly real is physical stuff, matter and energy, and that's it. Let's just pause and really sit with this question, because it's the absolute heart of the issue. Our best theories of the physical world completely depend on something non-physical: numbers, equations, mathematical ideas. So if that's true, how can anyone claim that the only thing that's real is the physical world? It just doesn't seem to add up.
So let's just walk through the logic here step by step. First, mathematical things, like the number 2, they seem real and objective, right? Their properties don't change based on our opinions. But they're not physical. You can't hold the number 2. It's not made of atoms. And yet, our understanding of the physical world is literally impossible without them. So the conclusion seems to be that a purely materialist view of the universe is, well, it's incomplete. It's missing something huge.
The philosopher David Berlinski puts the mystery just perfectly. He says, look, forget for a second how useful math is. Just the fact that it exists, this consistent, non-physical, but totally objective thing, that in itself is deeply, deeply puzzling. His question is simple. What is it doing there? So if we accept that mathematics is the language of the universe, and that language is built on these strange objects that aren't physical but are undeniably real, it leaves us with one final, haunting question. What is this language truly describing?